Hi guys, good morning all of you. Hope all of you can hear me. Anyone guys, can you please confirm is audible?
Yes, sir. Yes, sir.
Right, right. So guys, just before starting the session, I think some new guys has joined. I think yesterday and today. Can anyone guys, can you please confirm who has been joined yesterday and today's class? So just if we can type, remaining people don't know, it won't require. Just I want to know how many people has joined for the today's class or how many people has joined in yesterday's class. So just can you type it in the chat window like today is your first class or second class? Anyone guys, can you all of you who has joined in the yesterday's and today's class? Just let me know like how many of them has joined in the yesterday, today's class. So today is your first class. Okay, first class. Yeah. Anyone? Today's second class. I think yesterday somebody has joined. Anybody? Yeah, Ashok, today is your Vinith, your second class. Okay, Ashok, it is a first class. Okay, fine. So yeah. So guys, okay, so the guys who has already joined yesterday already explained about the session. This session was already started, guys. So we currently started with the Python basics. So a little bit Python basics has been completed, guys. And yesterday only I started with one of the basic prerequisites for data science is NumPy. So if you already have the idea about the basics of Python, well and good, you can continue. You can just continue. Even if you don't have the idea also, don't worry. These are all only just the prerequisites, guys. It's not a mandatory topics. So we just core concepts of Python we completed, guys. So core Python I have discussed. So I already discussed about some few points. Yesterday I started with my first Python library called as an NumPy. So this is the foundation for our data science. So from yesterday I just done the introduction only. So the guys who has missed the previous classes, no need to worry about all the previous classes. You can learn the core Python topics, guys. That is not going to be that much complex. So you can easily learn the core Python topics. We can learn it, guys. Easily we can learn. By yourself you can learn, as well as I'll also give you the recorded videos also. Whatever the sessions that you have missed, the recording videos I'll give you. So once you registered for the course, I'll give you the recording videos. You can go through the recording videos, guys. Okay. So that is the one thing I can suggest you guys. Remaining, you no need to worry about that. We have not yet started with any main concepts of data science. So the first introduction I have started is NumPy. Yesterday only I have started with the NumPy library. Just yesterday, just an introduction I have started, guys, not more than that. So just go through the session, guys. You can understand the topic. So just we can continue for 1 or 2 days of time. So once if we can, you can think if you can, if you are confident that you can continue the session, you can just continue the session. Meanwhile, what you can do is, guys, tomorrow and after tomorrow, anyhow, there are some holidays. Tomorrow you don't have a class. Monday, Sunday also you don't have a session. So meanwhile, these 2 days, we can just brush up the core Python topics if we have with you. So, and after that, you can just continue with the next coming classes. That is only prerequisites, guys. There are not mandatory topics, just a basics only. You can understand the topics, guys. Okay. So fine. So let us continue with the last session. So in the last session, I just started with we discussed about modules. A different modules I discussed. What is a module I discussed about in Python? It's like a .py file, which is going to contain a set of classes and set of the methods are set of classes and which are going to be having a set of functions will be there. And it will be available as a .py file in your system, guys. Nothing is there. The module will contain a set of classes and set of functions will be there. We have to just import the module and you can use the classes and you can use the functions which are related to the module. And we discuss what are the base module is going to be there. Built-ins is the one of the base module, guys. So whatever we have worked recently, all of them are going to be belongs to the built-ins module. And after that, I explain about math module. We discussed about OS. Yesterday in the last class, we discussed about the date and time. And yesterday we discussed about something about the arrays. So these are some of the extra libraries we discussed about modules, what we discussed. And yesterday I just started with a basic introduction to NumPy. So today also we'll continue with the NumPy introduction, guys. Have a look into this. What is NumPy? NumPy basically stands for which is going to be its numerical Python, guys. Once again, what is the NumPy stands for? It is basically stands for numerical Python. And as I said that today really we are here to learn about data science. We are learning data science, we are learning machine learning, we are learning deep learning. So in the recent years, they have become very popular implementations or the popular techniques, guys. So really why they have become popular, why? Because it is completely due to this library called as an NumPy. If as of now, if really NumPy was not existing now, as of now, still this data science and machine learning is only up to the research level only, they used to be there, but we would not get this into the implementation. So today we are really working with this machine learning, we are learning, we are implementing, means really it is going to be due to this NumPy library, guys. NumPy is the basically the one of the basic foundation. It is the one of the basic foundation for the, which is going to be the basic, it has laid the foundation, guys, for which is going to be the foundation for the scientific computing. So today, almost all whatever the libraries, I'm not saying that NumPy is completely using NumPy we can implement, but today whatever the libraries we are nowadays we are using is completely developed on top of the NumPy. So many libraries, guys, almost all every scientific computing or every scientific applications is depends on the NumPy. So we will use a library called as an pandas. Pandas depends on the NumPy. Pandas depends on the NumPy. Even not only that, even all the data visualization tools like Matplotlib, Seaborn, okay, even all the machine learning libraries like sklearn, and even some advanced libraries like TensorFlow, or we are having the PyTorch. TensorFlow was developed by Google AI team, guys. TensorFlow was developed by the AI team from Google, and PyTorch was developed by Meta, that is Facebook. The Facebook AI team has developed this PyTorch library. But all these they have been inspired, and they have been completely inspired from the, which is going to be the NumPy. If NumPy was not there, no pandas, no matplotlib, no seaborn, no scikit-learn, no TensorFlow, no PyTorch. So if these libraries are not there, no machine learning, no data science. So we have to just, it is going to be we don't give much preference for NumPy, guys. As I said that no, hardly 3-4 days only we are going to work with the NumPy. So NumPy, basically what is the NumPy provides you, guys? It provides you some arrays only. So yesterday in the last session, we discussed about arrays, Python arrays. But there is a lot of issues with these Python arrays, guys. These are what we call it as NumPy arrays, something different from them. I'll explain them. Let me open and I explain you, guys. This library or this module or package was not developed by Python team. It was developed by another community called as an NumPy community. So it was contributed to Python, but it was not developed by Python community. This math, OS, date and time, arrays, these are all completely developed by the Python core team only, guys. There is a Python core team will be there. They developed these libraries, but these are not developed by Python core team. It was contributed to the Python, guys. Why? Because it has been developed with the help of the Python. So what they did is, Python is an open source. So without spending any money, they developed this library, taking the source code from the Python. That's why what they did is they contributed back to the Python. So if you want to get all the documentation for this, I told you guys, it is going to be docs.python.org. So if the documentation is coming from docs.python.org, means it is created by Python core team. But when you ask for NumPy, it does not come from this from python.org. It is going to comes the documentation from numpy.org, guys. Let me open numpy.org. Open the numpy.org, guys. You will understand this. I'll explain this. What is this NumPy and all the, what is the advantages it provides, all these things I'll explain you. So don't go to python.org, guys. Python.org does not provide you any documentation for NumPy. Why? Because NumPy is contributed. It's contributed by a separate community. See there, the fundamental package for scientific computing with the help of Python. Similar to NumPy, we have one more is there, guys, SciPy. It is going to be, what is SciPy stands for? SciPy stands for, which is going to be scientific Python. See the website once carefully, guys. See the, whatever the logo, only the logo will be different, guys. See there, this is NumPy, this is SciPy. NumPy, SciPy. See, That design and everything looks like the same only, guys. See there, NUMPY, num n capital, SciPy, C capital, P capital, guys. What is this? This is fundamental algorithm for scientific computing in Python, and it is going to be the fundamental package for scientific computing in Python, guys. Got it? It's a fundamental algorithms for scientific computing. This is fundamental package for scientific computing in Python. See there, looks like exactly the same. Even design also, guys, looks like the same only. Check it out, isn't it? Can you see? This is going to be SciPy, guys. So SciPy is also one important library. So let us talk with the NumPy, guys. See the NumPy library, guys. I'll come back to that. Come down. Just come down, guys. Almost all, this NumPy is a fundamental package for almost all scientific computing. Scientific computing means almost all every domain, guys. It's not only this domains or that domains is getting the advantage. Almost all every domain, guys, including almost all every domain that exists in the real time, guys. Like which is going to be not only the data science people or not only the data analyst or not only these people, guys. Almost all everyone, even some kind of an like which is going to be astronomy. So the astronomy related domains uses the help of the NumPy. Okay, and which is going to be geospatial analysis, geospatial, there are also going to be using them. Chemistry is using, guys, the physics, quantum computing. Okay, all those are going to be taking the help of the NumPy. Even some departments like psychology, they're also using this. Okay, almost all every domain, which is going to be statistician, mathematics, chemistry, physics, okay, geology, astronomy, almost all every domain, guys, every domain, every scientific computing using this. Come here, and once you check it out, guys, come down. Okay, come down, guys. If you can observe carefully, this is what it is saying as scientific domains. Nearly every scientist working in Python draws on the which is going to be powerfulness of the NumPy. See there, guys. All these are going to be the different domains, as I said that. So the quantum computing is using, these are the libraries, guys. See there, these are the libraries. Bioinformatics, BioPython is there, scikit-bio is there. Okay, statistical computing, as I said that, right? Pandas. Signal processing, SciPy. So even just now shown, SciPy, it is also depending on the NumPy library, guys. Statistical computing called as a Seaborn. Image processing like OpenCV, and which is going to be the scikit, which is going to be scikit image. Astronomy like AstroPy, SunPy, SpacePy. It's going to be some cognitive for psychology, which is going to be PsychoPy. It is going to be geographic, geoscience. Okay, mathematical analysis, bioinformatics, chemistry, geographic process is there, architectural engineering. See, guys, almost all every domain is there here, guys. Every scientific domain I'm talking about. Every scientific domain is depending on the NumPy. So NumPy has really contributed a lot to this scientific computing. See there, come here, our subjects. We are not bothered about astronomy. We are not bothered about the psychology. We are not bothered about the chemistry. Come to our subject, guys. What is our subject? Data science, isn't it? Go to the data science, guys. So already yesterday, just an example. See there, NumPy lies at the core of the rich ecosystems of database, the data science library. So if you can see an exploratory, which is going to be data science workflow is going to be looks like, see there. So extraction, transformation, and loading is done by pandas. Exploratory analysis can be done by Seaborn and the Matplotlib. Models and evaluations are done by scikit-learn and stats model and spaCy. And reports in the dashboards are going to be Dash and Panel and Voila. These are all going to be all the libraries which are completely depending on the NumPy, guys. If NumPy was not there, no data science would be there as of now. Machine learning, as I told you, machine learning, it's a scikit-learn. We are having a scikit-learn, we are having a PyTorch, we have a TensorFlow. All these has been completely depends on this one, guys. See there, scikit-learn, SciPy, machine learning grows. So the first library is built on the NumPy. TensorFlow is a deep learning capabilities having broad application. It was developed by Google AI team. And there is going to be the time series analysis and video detections. PyTorch, another deep learning library. It was developed by the Facebook, that is Meta AI team has been developed. So researchers in computer vision and natural language processing, they use as a PyTorch. These are all the high level, advanced level libraries, guys. Very high level, advanced level libraries, which are going to be used as part of the machine learning, deep learning applications. and even visualizations also. As I said that, right? Matplotlib, Seaborn, Bokeh, Plotly, Dash, all these are going to be, guys. Seaborn, Plotly, which is going to be Matplotlib, Bokeh. All these are the libraries which completely depending on the NumPy, guys. So mainly the NumPy has accelerated, what is accelerated? It made things faster, guys. Of large arrays allows research to visualize the data sets far the large than the native Python could handle, guys. So they can handle a very large volumes of data. Very faster they can be performed the numerical calculations. So that is the main advantage of using this particular the NumPy library, guys. See there, I already given some what are the different types of array libraries are there. PyTorch depends on arrays. TensorFlow depends on the arrays, guys. See, all these are going to be some of the libraries what we can talk about them. Okay. So anyhow, this is going to be just the whatever the introduction of NumPy. So even I'm discussing saying that it is very useful and very powerful, but we'll spend only 4 to 5 days or 3 to 4 days we are going to spend, not more than that. So what is the main advantage this NumPy provides you, guys? Mainly, NumPy provides you all the utilities. Mainly all the utilities which are basically used for mainly for numerical calculations, guys. Almost all numerical calculations can be gets done, guys. Almost all as a mathematician or a statistician or a scientific research, whatever the mathematical calculations are there, that will be supported by the numerical Python, the NumPy library. Examples I can say, it supports which is going to be performing the operations related to linear algebra. We'll do it now, guys. Some linear algebra calculations we are going to do. Matrix multiplications, matrix additions we can do. We can do something called as a Fourier transforms, what we can do. Almost all mathematical related operations, linear algebra, matrix calculations, matrix multiplications, additions, Fourier transforms, random number generations. So some kind of a random number generations, guys. So these are all going to be the some of the utilities which are provided by this NumPy, guys. And mainly the data structure it will support is going to be nothing but what we are going to call it as NumPy arrays. Simply we call it as NumPy arrays, guys. What is it? What is the difference between a NumPy arrays and yesterday's whatever the arrays we discussed? Yesterday I discussed about some basic arrays in Python. But I have shown you we cannot perform the numerical calculations, right? When I created an array, how did you created an array, guys? It is array.array. Array is the name of the module. Array is the name of the module. Array is the name of the class. Integer I, comma, I specified some values, guys. 10, 20, 30, 40, 50. So this is the whatever the values we given. But though you created an array also, we can't perform any calculations directly on the arrays. We unable to perform, guys. I said a equal to, but when I said a multiplied a to the power of 2, it didn't allow the operation. It didn't allow the operation. But what is the main advantage of using NumPy arrays is, guys, directly we can perform any mathematical calculations, guys. Any mathematical calculations can be done directly on the which is going to be in arrays, guys. Direct operation. You don't think about any other thing. Directly take two arrays, add up them. You multiply them, you divide them, you do any calculations. Almost all mathematical calculations are allowed, guys. And one more important point here is, normally we know that these arrays or lists, whatever we created, guys, they contains only one dimension, just sequence of elements. That's it. A sequence of elements, guys. Just we can define an array. Generally, we all of you have an idea. Array is nothing but just only a one-dimensional arrays are there. But how about a two-dimensional arrays? How about three-dimensional arrays? These NumPy array supports, guys. These NumPy arrays are multi-dimensional, what we can say, a multi-dimensional arrays, guys. They supports working with multi-dimension arrays. Simply, we call them as an ND arrays, guys. Why ND arrays means n is nothing but n, some number, dimensions, n number of dimensions, 1 dimension, 2 dimension, 3 dimension, 4 dimension, will create as many you can create, guys. Why? Because mostly in scientific computing, we have to work with n dimensions only, guys. If you try to work with a normal single values, it takes a lot of time, guys. That's why practically what we are going to do, guys, we are going to use n dimensional analysis. So it is going to be n-dimensional arrays, which we are going to call it as ND arrays, what we are going to call it as. We call it as ND arrays, what we are going to call it as, guys. So mainly multi-dimensional arrays and any mathematical operations and performs all the numerical calculations and very faster calculation, guys. So NumPy arrays internally uses some kind of a techniques to make almost all any calculation very faster, guys. So faster compared with the other numerical calculations, numerical libraries, supports multi-dimensional analysis. Any mathematical operations can be done directly. Plus, it allows you to perform almost all any kind of numerical calculations like linear algebra, matrix multiplications or matrix calculations, Fourier transforms, random number generations. All these are the some of the features which NumPy provides. Open the NumPy library. You can see, guys, what is an advantage. See there, powerful n-dimensional arrays, guys. So as of the latest, whatever we are working with scientific computing, guys, we completely depends only on the whatever the default standards we are using of arrays is nothing but it is n-dimensional. Fast and versatile, the NumPy vectorization, indexing, broadcasting concepts are the de facto standards of arrays computing today, guys. And one more point, numerical computing tools. So almost all mathematical functions like linear algebra generators, random number generators, linear algebra routines, Fourier transforms, and many more are there. Open source, free to use. Open source, guys, there is no need to pay any money for that, and free to use, guys. And apart from that, it can be it can works on any kind of a platforms, guys. So it works with GPU, CPUs. It's going to be interoperable with any kind of an architecture. They will works and easy to use, guys. The syntaxes are also very easy to use. So NumPy high level syntax makes it accessible and productive for programmers for any background or experience level. As I said that, right, there is nothing requirement is there. Even if you miss the previous classes also, nothing matters. From today onwards, you start your learning, guys. Just how to import the library, just only the setting, the environment is different, guys. Maybe we have to know about that. Otherwise, everything is going to be the same as it is. So very easy to use and very easy to learn. But today, I just start with some basics of NumPy, some basic calculations and all these things I'll show you. Anyhow, I'm going to use a Jupyter notebook, guys. Okay. From last couple of classes, I'm not using Jupyter notebook. Already I discussed about how to install this Jupyter notebook, guys. So the guys who has missed the previous classes, don't worry as of now. Okay. You can even work with any environment if you have with you, or else later I'll tell you how to install it. So Jupyter notebook I have installed along with which is going to be Anaconda Python. For a simple technique, I'll just tell you guys. You please download this Anaconda Python, guys. Once you install Anaconda Python, we'll get Jupyter notebook. That's it. Blindly you remember like that. Just 2 minutes, guys. I'll finish off it. The guys who has already done the installation. Just nothing is there. I'll share you the link. If anybody wants to have as missed the previous classes, you guys can install it, guys. See there, go to anaconda.com. Go to anaconda.com, guys. It is one of the best platform for data science people. It is created by data science people, and for the data science people it was created. That's why they says that created by data scientists for a data scientist. Okay, can you see there is a free download was there, guys? Click on the free download. Just click on the free download, guys. Okay, this is not required. Even if you give it or give it, does not matter. Skip the registration, does not matters with that, and directly you can download and install it, guys. See there, this is the one which you have to install. Just download it, guys, and install it. Okay, just download, install it. Installation is very easy, guys. Next process, anybody can install it. So just do the installation, guys. So go to anaconda.com. There is a free download is there. So click on that particular free download, skip the registration, and then just directly install it, guys. Next process only. Nothing process is there in the Anaconda installation, guys. Once you're done with the installation, just 1 or 2 days, guys, it will be little bit difficult for you, but later you can easily, we can understand them. See there, here Anaconda is there. They go there and simply start this Jupyter notebook, guys. Just click on the Jupyter notebook. It will launch us the Jupyter notebook. Just nothing is there. Jupyter notebook is nothing but a web-based environment, guys. A web-based environment where we are going to work some kind of just writing the script and all these things, whatever you can write. And even not only Jupyter Notebook, we have other IDEs are also there, like PyCharm is there. We have a Spider is there, or we have a Visual Studio Code is there. Anything, guys. You can use any environment, whatever you want. I recommend to use which is going to be this particular Jupyter Notebook, guys. So last 1 or 2 days only I have used it, guys, not more than that. Mainly I have written the conditional control statements, comprehensions, string class, and functions topic. Only 5-6 topics I have been covered using the Jupyter Notebook. Let me open it, guys. You can understand it. Just 1 or 2 days. You just try to work on it little bit carefully. We can understand it, guys. Let me open it. This is your what we can say the Jupyter homepage, guys. Nothing to do. Simple. Here there is a new option will come. Just click on this and click on the Python 3, guys. Just writing the code and executing the code. Very easy, guys. Just write the code and just execute the code. Just the shortcuts will be there. 1 or 2 shortcuts will be there. We have to learn those things. That's it. Let me open the Jupyter Notebook. That's it, guys. See there? Just you have to write the code and you have to click on the run button or control plus enter, guys. So you can add up the cells like this, adding the cells like this. Very easy. It's not that much complicated, guys. Now, okay. So before going to that, okay. Yeah, let me complete of this. After that, I'll discuss about import, which is going to be, import, which is going to be in NumPy. This is the way we have to import in, guys. Why? Because NumPy is not a default library. It won't be preloaded. We have to load in, guys. Simple. Import NumPy as an NP, control enter. It will run the code and the NumPy library will be important, guys. Ready to use. See there, import NumPy as an NP, guys. It is now NumPy library was ready to use. How to work with them, guys? Very easy. So first today, it's very simple. First class of NumPy, right? I'll do a very basic level, guys. See there, just for a small timing, guys. Don't worry. Marks equal to, I want to define some students' marks. First, I'll create some list, guys. Just an example. 54, 50, 45, something like 35, 78, 82, 90, something like an 70, 70. As you already know that, all of you know that this is going to be type of the marks. It is nothing but list. See, guys, I'm adding a new cell. But as you know that directly on these marks, I can't calculate. For example, let us just an example, guys. These are the students' marks. So I got the marks here. These are the students' marks. Now let us say that I want to add 5 marks to every student. I want to add 5 marks. Let us say that sometimes you know that, right? After the exam is completed, so some questions has been given wrong. So they want to add 5 marks to this each and every student. So they will say marks plus 5 marks. Execute and check it out, guys. I'm trying to add the marks plus 5. We cannot do it, guys. Why? Because it appears like they will allow, but they don't practically allow, guys. Next, one more thing we'll do, guys. We'll import the array library. Yesterday we discussed array as which is going to be A. For example, I'm using normal. These are Python arrays, guys. There are not NumPy arrays. There are standard Python arrays. There are very limited usage only. A dot array of, yesterday we discussed, you know, guys, I, comma, the same marks I will define it, guys. Same as it is, the same marks I'll copy and paste it. Same marks I'm copying and pasting, guys. This is also, I write it as marks. This time marks is equal to what? This time, just a minute. Right. This is going to be marks, guys. What is going to be type of the marks? It is not list. It is going to be array.arrays. They are going to be array.arrays, guys. Now try to do the same calculation. Marks plus which is going to be 5. I want to add 5 marks to each and every student. Not possible. List is not allowing, guys. Your list is not allowing. When you try to use this particular list, marks plus 5, it is not allowing. Clearly, it is saying that it is not allowed between an integer and a list, because marks is a list, 5 is an integer. We can't do that. Even it is also saying the same thing. I cannot do between array and an integer. But who will allow? NumPy arrays will allow, guys. See, same example, how to convert this into a NumPy array. See, I'm going to create a NumPy array, guys. How to create it? Marks equal to, careful, guys, it is np.array. This is a.array, guys. This is np.array. Both are different. This will create a normal standard array. This will create a NumPy array. No need to specify any type, I, j, no need to specify. The NumPy will decide it. Same values as it is, copy and paste it, guys. Same values, copy and paste it. Now ask what is type of the marks. Clearly, can you see numpy.nd array? Why it is specifically saying nd array? Multi-dimensional arrays, guys. I will discuss about what is 1D, what is 2D, what is 3D. We'll discuss about them later. But this is going to be your marks, guys. See the marks once? Very clearly, simple. Once you print the marks, you can see that it is going to be an array, guys. Marks equal to this much. Now, same technique. I want to add 5 marks to each and every student, guys. Marks plus 5. There is no restriction, guys. You can immediately, you can do the calculation. Do you find the difference, guys? What is the main problem with the list? List is only for creating a sequence, but we are unable to perform any manipulations on that. So why should I create an array, guys? Why should I create an list? I want to do some manipulations, but I cannot do the manipulations. Even Python standard arrays also not allowed. They don't allow that. But you see NumPy arrays, marks plus 5. 54 plus 5 is 59. 40 plus 5, 45 plus 5 is going to be 50. 35 plus 5 is going to be 40. 78 plus 5 is 83. Then the calculation, guys. If you want to subtract 5 marks from everyone, marks minus 5, it is going to be, it's going to be 49, guys. 54 minus 5, it is 49. 45 minus 5, 40. It is going to be 82 minus 5, which is going to be 77, guys. Done? So like this, we can just perform any kind of calculation. Not only this, guys, any kind of calculations we can do. Take 2 arrays, add up them. For example, let me show you guys maths marks. How many maths marks the student got? Let us say that maths is equal to nothing but np.array of, just give the marks, guys, 80, 93, 90, 87, and 75. Just I'm taking 5 students. What about the physics, guys? What about the physics marks? Physics marks is equal to nothing but it is np.array of, let us say 84, 79, 93, or 92, whatever it may be. Something like 80 and something like an 82. And let me take the chemistry marks, guys. It is going to be chemistry equal to np.array. You have to say np.array, guys. Otherwise, it becomes a list. Okay, numpy.array. np is the name of the module. Array is the name of the class. np.array of. So whatever the values you require. Again, which is going to be, let us say 90 or 90, I'll take it. Or some example 92, 88, 79, something like 85, guys. So these are the maths, physics, and chemistry marks respectively, guys. Now I want to find out what is the total marks obtained by the student. So 5 students in maths, 5 students in physics, 5 students in chemistry. Now what is the total marks, guys? Simple. What is going to be total marks? I just want to add up this particular arrays. Simple. Maths plus, which is going to be physics plus, and which is going to be chemistry, guys. Then what is going to be the total marks? That is another array, guys. 80 plus 84 plus 90. If you want, you can add up them. 80 plus 84 is 164. 164 plus 90 is going to be 254, guys. Total marks. See, guys, how simple we are able to do that. You don't require anything like loops and all these things, not required. Directly, we can add up the things. But in the place of the NumPy arrays, if you try to use something like list or something like a standard arrays, they don't allow. They don't allow you to perform the operation. We have to write some loops and all these things, and we have to do them. We can do them, but directly we can't do them. But here, directly we can add up the values, guys. Not only this,
Sir.
even any, yes, hello.
Sir, one question. So
yes, go ahead.
This NumPy, we are not even providing any data type information, right? Like I or something like that.
Yes.
By default, the basic data type is taken.
Yes, it's not basic data type. Which one is an appropriate data type? The NumPy automatically chooses.
Okay, if you are creating like a custom object or custom class, and then if you are adding to the array, will that also work in a similar way?
Yeah, it will take it, but all types of data structures may not be supported. Maybe. Okay, we'll see them when you go to the next level. That means we'll create 1-dimensional, 2-dimensional arrays, 3-dimensional arrays. Then you will understand that particular concept. But if you observe the documentation of the NumPy, for example, you see there, Shift plus Tab, if I press it, you will get the documentation. See, I'm giving the object. Can you see there is something called as a data type concept is there?
Yes. Yeah.
Okay, so what is the data type will be done is, it's an optional, it's not mandatory. See, if not given, NumPy will try to use a default data type. that can represent the value. So if you give integers, so as of my knowledge, you can ask it. Okay, don't worry, you can ask it. So see, I'll show you what is going to be D type. So it is saying that what is the data type? It is saying that it's a 32-bit integer data type. It is saying. Okay.
Okay.
For example, if I said here.
So this is like a custom data type in NumPy.
It's not a custom data type. Every library will have their own data types. It will be there.
Okay.
Okay. We can say that there are built-in. We cannot say that it is custom. Now, if you observe carefully, I added 75.4. So automatically 75.4 means can it take it as an integer value now?
Nope.
No, isn't it? So see, then Python, the NumPy automatically chooses it. It has chosen as a 64-bit a float type of data type.
Okay, yeah.
Okay, so
but in default one, right? It was like class float or class int, right? This is somewhat different with 64 or
this
something.
is different. This is different.
Yeah.
That is Python standard library. This is going to be NumPy standard libraries.
Okay.
It data type changes. Just for a quick understanding, if you want to know about that, you can say np dot. Once you say np dot, you will get all the list of the whatever the data types we have it. See, integer 16 is there, 64-bit integer, 32-bit integer, 64-bit integer, 8-bit integer. If you go for a float, so once you go for a float, it's a 16-bit float is there, 32-bit float is there, 64-bit float is there. Like that, there are going to be some built-in types. According to that only, it is going to take it.
Okay. One more question, sir.
Yeah.
So normally we are doing an import, right? So for the modules which are other than built-ins, we are doing an import.
Yes, yes.
Some scenarios we are requiring like a pip install, right? When do we really need that?
Yes, absolutely. So see, basically, we install the Jupyter notebook with the help of Anaconda Python, right?
Yes.
Okay. What is this Anaconda Python? Anaconda Python is a what we can say that it's a distribution of Python. Basically, we call it as. Mainly, why we prefer to go for Anaconda Python means it will comes with, it not only comes with Python, it is going to comes with all the which is going to be libraries, which mostly the data science people are going to be required. Majority like scikit-learn, NumPy, Pandas, Matplotlib, Seaborn, all these libraries will come by default. Sometimes we have to install some additional libraries we have to install. So in that cases, you have to install it separately by using something called as an, in my system, most of the libraries will be installed. In your system, if you try it, it won't be there. For example, I'm importing which is going to be CV2, for example. This CV2 is already there. Observe carefully. It is saying that import CV2. Is it there or not there?
It's not there.
It's not there. In that case, what we will do is I will install it. See, simple command. It is pip install. Pip is an utility. It is going to be, it is opencv, just a minute, opencv hyphen, it is going to be, sorry, opencv hyphen Python. Just give me a minute. It will install this library. So what is this library? Why that it is installing is, recently I have updated my Anaconda Python. I uninstalled the previous one and there is an update was there. That's why I have installed. NumPy not required to import. We need not to install. NumPy, Pandas, Matplotlib, Seaborn, all the standard libraries we don't require. But whenever you want to work with some additional libraries like this, you have to do that installation. So now it is doing the installation. Pip install opencv-python. Just a minute. Let it install it once. So can you see it is installing? Done, right?
Yes.
Okay.
Yeah.
Now I can say import CV2. Now it is imported, right? Now I didn't get any error.
So now if you are taking multiple libraries, right? There can be like that same module can be present in two different libraries also, right?
Same. Once again, can you repeat?
For example, if CV2 can be found in two different pip libraries, whatever we have installed.
No. It will not be available like that. It will
so
be
it
always
should be
unique.
Like globally unique.
Globally, it will be unique. Yes, everything it is going to be unique.
Okay.
It will not be like that. If you install, if you're trying to install Pandas, for example, pip install Pandas. So obviously what they will do is, maybe the references may be multiple, but finally that will be coming from the same package only. It has to come basically. So references may be different, but it will come from the same package. See, Pandas was already installed in my system. So when I try to install the Pandas once again, it will say that requirement has been already satisfied. So if it is already there, we'll get the message like this.
Okay, yeah.
Okay. So maximum why we prefer to go for Jupyter Notebook through Anaconda Python because is, if you see the Anaconda Python provides you all this. Normally, if you're working out of Jupyter Notebook, maximum you have to install the libraries. Got it?
Okay.
So
Yes.
we'll generally what we will do is, for example, I want to work with idle. See, I want to work with idle. In idle, what happens? Where is that idle actually? This idle comes along with the whatever the idle is nothing but this is a base system which we downloaded from Python. Most of the libraries will not be available. Even if I try to import, let me check it out. Import, which is going to be like, for example, import Seaborn. Let me check with the import Seaborn whether it is there or not there. I think recently only I have installed it. Sometimes most of the libraries will be available. Just let me check. Seaborn, import Seaborn. Just give me a second. Just give me a second. I think it is there. It is loading. It's taking some time. Why? Because it's a huge library, so it will take some time. Okay, import bouquet. There is a library called as an bouquet is there. Import bouquet. That is also there. Import, which is going to be Plotly. I think recently we have installed all these libraries. That is the reason. NLTK. Import NLTK. I think NLTK is also there. It is we have installed already. Okay, fine. Some time being. So whenever you want to work with these libraries, because these libraries we already install it separately. So we'll open a command line utility like this. You're working out of the Jupyter Notebook, right? So in command line, we have to write like this: pip install, which is going to be nothing but pandas. So then only that will be gets installed. But when you work with the Jupyter Notebooks, most of the libraries we need not to install it. Why? Because Jupyter Notebook, which I have installed along with this Anaconda Python. See, just let me show you. Skip the registration. Just you see, just have a look into that. So what it is saying, observe carefully. What is this Anaconda? What is this Anaconda saying? That is, so it is going to comes with so millions of developers and data scientists research, innovate and discover using Anaconda distribution. So Anaconda Python comes with almost all around 8,000 open source data science and machine learning packages. Jupyter Notebook will come, Spider will come, NumPy will come, TensorFlow will come, PyTorch will come, Pandas will come, Matplotlib, Conda, sklearn, Bouquet, Dask, almost all, SciPy, almost all libraries. See there, approximately somewhere around 8,000 packages are ready to work with them. See there, these are all package categories. If you see all the packages, which packages you want for scientific calculation, image and signal processing, whatever you want. So these are all the libraries what we can see them. You can search for the packages. We can search for the packages. See there, this is going to be the packages. Numerical calculations and all these things, if we can see, NumPy, which is going to be, these are some of the packages which are contributed. See there, like this, something what we can see, these particular packages, visualization related packages, Matplotlib, Bouquet is there, Seaborn is there, Plotly is there, Graph is, all these are libraries which comes along with this Anaconda Python. No need to install separately. So that is the reason why we prefer to go for this Anaconda Python. Why? Because almost all related libraries and everything, machine learning and AI is there, natural language processing, AI related applications, scikit-learn, TensorFlow, and PyTorch. These are going to be. So what are going to be the natural language processing, NLTK, PyTorch. PyTorch is also for basically for the same thing. So these libraries are built in. They comes along with them. That's why we don't require to work with them. Additionally, if you want to require, we have to install them separately. Okay.
Sir, when we are installing this library, right, there will be like a default configuration for the package manager, right, which is the common Python's library.
Yes,
you can also have your own organization's override as well. Where do we configure that actually?
Yes, absolutely. We have to do that. That is a little bit higher level. We'll see them later. Once you work with a little bit advanced level libraries, then we can see with an applications with that.
Okay, yeah, sure.
Generally, I done up to now, I never done it, but I know that how to do that, but we never requirement to do. We'll do some customization at not at higher level, at lower level, we can do some customizations. We'll see them, how to customize those particular packages according to our requirement.
Okay, yeah.
Okay.
Thank you.
Right. Okay. So, yes. Anyone, guys? Any questions?
Yeah, sir. Just I have joined 3 to 4 minutes before.
Okay.
I want to ask you regarding this question. I will tell you about myself. So I am a Python. I have experience in Python. So I worked in
Okay.
framework in Django and my previous
Okay.
organization.
Okay. Okay. Okay.
So I'm looking forward to move my career to data science or data. So I'm little bit much confused. What should I pick up? Data scientist or a data analyst? What is the difference between that and what would be the pathway to achieve this?
Okay.
That's why I was not finding any.
Okay.
I was
Sure.
not getting an answer.
Yeah. Yeah.
Can you
Yeah.
clear
I'll
my
discuss.
idea?
I'll discuss it. Okay. We'll do one thing. We'll discuss it offline because currently session is going on. I don't want to take a break for this. Let me complete
Okay.
off it. I'll give you my contact number once. Just once after the completion of the class, just text me or you can just call me. We can discuss over it.
Okay. 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 Share
Okay.
me your number in the
Yeah,
chat.
I'm sharing the number here now. In the chat window, I've shared with anybody, guys, not only you, anyone.
Okay.
Already we have created a group also within 1 or 2 days. Once you register for the course, I'll make you to join the group also. So in the group, we can have a discussion. So I've shared the number there, right?
Okay. Okay, sir. Thank
Right,
you.
right, right. So let's go ahead, guys. Let's go ahead. And this is going to be the, see guys, how simple the valuations are able to do that. So direct calculation, just like how you do the calculation with numbers and etc. Directly we can do that. Not only this, all mathematical functions. For example, let us say that you want to find out what is the square root of this total marks. So each and every mark square root, I want to find it out. Some example. Normally, whenever I said square root, yesterday's the last day session, guys. Immediately, what you will do, guys? Import math as m. But what is the problem with the math? What is the problem with this m, guys? It is only can perform square root of only single number at a time. It cannot do on the total array at a time. You can't do it, guys. See there? If I said m dot square root of total marks, you'll get an error. Why? Your math library works only on scalar values. So what is the solution for that? We have a solution for I in which is going to be total marks. You can do like this now, guys. Get one by one marks, we can get it. And I can say m dot, which is going to be square root of I. This is one solution, guys. But no need to do all the solution, guys. We don't require help of any other libraries. NumPy says that, do you want to perform any calculations? You do it. We already provided the libraries. Only thing is np dot square root. So what is the difference between np dot square root and math dot square root, guys? Math dot square root will work only on single scalar value. np dot square root will works even on a single scalar value, or else even it can also works on a array also it can works, guys. It can work on a single scalar value. You give a single scalar value, it will works. Or even if I give a list of values or an array of values, it will work. See there? Why should I write all these extra things, guys? Directly np dot square root. Anything, almost all functions, guys. np dot, which is going to be log 10. So scientific calculation means only these, no, guys. Logarithmic, square, power, natural log, sine, cosine. These are the values. np dot, which is log 10 of what is going to be total marks. Do you want to calculate logarithmic value to the base 2? Calculate to the base 2, guys. np dot calculate what is the natural log. Log stands for natural log, guys. You know what is natural log? Natural log is nothing but to the base e. So we can calculate it, guys. See there? It's going to be square root of the values. This is logarithmic value of to the base 2. What are the base 2 values going to be there? And this is going to be the base 10. This is base 2 and this is natural log. So see the advantage, guys. They can work with scalar values also. sp dot, np dot. I can say log 10 of which is going to be 10. In the last class also, in math library also shown you guys. But in math library, the problem is they can work only with a single scalar value. But when you have some array of values like this, NumPy can't, the math library does not works. It is np dot logarithmic value of 10, np dot log 2 of 10, np dot, which is going to be logarithmic value of 10, guys. Anything is the fine case. Whatever you want, we can calculate it. It is 10 to the base 10 is 1, 10 to the base 2 is going to be 3.33, and 10 to the base is going to be 2.30 something is the value what we can call it as. That's it, guys. So that is the way how basically we can work. Even math library also works. Even I can also do math m dot, which is yesterday we discussed, m dot log 10 is there, which is going to be 10, and which is going to be m dot, which is going to be, we are having m dot, which is going to be log 2 also there. But only problem here is, guys, m dot log 10 will works only on single scalar value, whereas np will works with multiple list of values it can work. See there, this is a way which we can see. Same results, but it is going to be done in a single step. It is going to do all calculation, guys, not this or that. Anything is fine. If you want to discuss, there are a lot of functions are there, guys. Do you want to calculate? So degrees into radians. Let us say we have something called as a degrees. Degrees is equal to np dot array of, which is going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Do you want to convert this into radians? Np dot, which is going to be radians of, which is going to be nothing but it's a degrees. All of them are converted into radians. Now I want to calculate sine value. Np dot sine of this particular degrees value. Sine 0 is 0, sine 30 is 0.5. Sine. So see the difference, guys. Normally, even math library is also having the sine. Np m dot, which is going to be sine. Sine of what we have to say, sine 30. But that need to be converted into radians. So for that, m dot radians. M dot radians of 30, guys, executed. I converted into radians. And I'm finding it, guys. But see, 0.4999999, almost all 0.5, guys. But math library is giving some approximate value, but this is giving an exact value, guys. See, sine 90. What is sine 90? We are getting 1. What is going to be the value? Sine, which is going to be 45. We'll say 1 by root 2, right? So it is going to be, you can see the difference, right? Sine 30. We generally say that sine 30 is 1 by 2. This is going to be 0.49999, which is equivalent to 0.5. NumPy is a little bit more accurate also, guys. More accurately it will work. 0.5. That is going to be the NumPy library. Anything is fine, guys. Anything you can do. NP dot, which is going to be cos. It is going to be NP dot. It is radians of, which is going to be, I said, which is going to be degrees, guys. So this is a value what we can see. Scientific representation. 8.66 into 10 to the power of minus 1. 7.07 into 10 to the power of minus 1. 5 into 10 to the power of minus 1. 0.5. This is 6.12 into 10 to the power of minus 17. Almost all 0. 6.12 into 10 to the power of minus 17 is almost all it is going to be 0, guys. So like this, we can work with this NumPy arrays, guys. That's it, guys. So these are just the basic calculations with the NumPy. So what I want to show you here is, if you really want to use NumPy, no need to depend on any extra libraries. Directly, NumPy provides all the utilities. What you want, tell me, I will do it. So do you want to create any calculations? Yes, I'll do that. Do you want to perform any functionalities like logarithmic scientific calculation? I'll do that. Not only that, even matrix additions, matrix multiplications, everything it will perform it by the NumPy library, guys. Okay. So this is going to be all about the concept of the NumPy application, guys. Okay. So that's it for the basic concepts of NumPy. In the next class, we'll start with a little bit more about the NumPy, how to create one-dimensional arrays. These are anyhow one-dimensional arrays, guys. What is 1D, what is 2D, what is 3D? We don't immediately study with the 3D. I'll tell you. You may have a different opinion about what is 2D, 3Ds. I'll explain that. What is one-dimensional arrays? What is two-dimensional arrays? First, we'll work on that. We do some manipulations on it. We'll do all the calculations, manipulations, everything we'll do. And after that, we'll see what is 3D, 4Ds, 5Ds also. We don't require them, but up to some extent, we'll discuss about those particular libraries, guys. Okay. So that's it, guys. That's it for the today's class. Anyone, any questions for the today's class? Anyone who has joined for the today's class, in the today's class, first session? Yeah, yes.
Sir, you have put that np.radians, right? What is that radians? That method,
degrees
what it
need
is?
To be converted into radians, right? Degrees conversion into radians. How to convert degrees into radians? So when 30 degrees is there, we call it as 30 degrees. It is going to be nothing but multiplied by pi by 180, right? We call it as pi by 6. It's a mathematical, scientific. We'll do the trigonometry, right? Sine, which is going to be sine 30, is going to be nothing but sine pi by. It's going to be pi by 6. It is. So pi by 3 is going to be nothing but 60 degrees, because pi is nothing but 180 degrees. It's nothing but we are converting into radians, like Fahrenheit to centigrade, kilometers to meters. Like this, it is going to be pi radians is equal to 180 degrees. According to that, we have to calculate it.
Okay. Yeah. So do you have any methods or something to brush up this mathematical concepts?
These are only just for understanding. It's not required. Whenever, if you really require, I can suggest you one. A small site is there. We can go for Math is Fun is there. So I generally recommend these applications. Whatever you want, we can calculate it. So little bit about the calculus, little bit about the algebra. So these are going to be some of the sites what I can generally recommend them. But right now it is
Can you
not
just put
required.
that in the chat?
I'll chat
Please.
it. I'll just
Yeah.
yeah.
Thank you.
But don't go beyond that. That means the problem here is you don't know which one you have to learn. So for the timing, skip them. It's not really not required as of now. Whenever if any requirement comes, at that time you will look into that.
Okay. So
okay,
one more question. So normally you said like arrays are restricted to certain types, right? The Python collection can't be restricted to a certain type. I know like it is heterogeneous, but is there a way to really convert it like that?
Oh, no. Actually, arrays are not heterogeneous. Arrays are homogeneous.
No, I mean like the collections are heterogeneous, but arrays are homogeneous.
Yes,
but
yes.
To convert a collection itself, is there a way in Python really?
You want to convert a collection into what?
Into a homogeneous type. Like now, normally in Java we use
okay.
generics and we
you can do
convert
that. You can do that. But what will happen here is there will be some restriction. For example, see, if all of them values are going to be homogeneous, you don't have a problem. But whenever we have something like a strings and numbers are there, then there is an issue will come basically. We'll do one thing. We'll discuss this on the next class once again. Just remind me in the before the starting the session. I'll generally remember if anybody asks a question. Generally, no need to remind me. I will just discuss about that. But anyhow, once again, just in the case if I forgot it, just remind me before the class. I'll explain.
Yeah, sure. Just one more question I have is NumPy. You said like it will use the GPU, right? There is an option to really use the GPU.
It can use a GPU.
I'm not really sure how GPU will really tune the performance. The basic logic for how it is really improving it.
It's an hardware. It's an hardware accelerator.
Yes,
it's not any programmatic.
Do we really
level.
need to understand something to really understand how it is really efficiently using it?
Yes. You have to understand the architecture of GPU.
Okay.
So simple. So see, it is nothing to do from our programmatical side. See, when you go to the Java programming, we have a multi-threading programming and all these things. There are some techniques are there. There's a programmatical techniques, right? So this GPU is nothing but just like, see, the difference between i3 and i5. So how i5 is going to be works better than the i3 means it is nothing but internal cores, the whatever the threads are there, performance threads, E threads will be there. Same as it is, that is also a hardware accelerator. GPU is like something like in gaming systems, we are going to get the GPUs. That will performs very faster. Number of threads will be more. Number of which is going to be cores will be almost double the CPUs. So that is a way it is going to be. But if you want to make your NumPy or anything to accelerate with the help of GPU, we require some libraries need to be extended. Otherwise, what will happen here is it will normally use as the CPU. We have to instruct saying that not by using CPU, we have to go for GPU process. We have to go.
Okay. Yeah.
Some programmatically, we have to attach that to our libraries.
Okay. Yeah.
Okay.
So if you are using a GPU based system, we are supposed to really check the libraries, whatever we are using.
Yes,
whether
absolutely.
It's compatible or not.
Yes,
okay,
absolutely.
Yeah.
Why? Because by default, it uses CPU by default.
Okay.
Okay. So when you go to PyTorch and all these things, you will know about that. Right now, it's not, we don't work with the GPUs.
Okay. Yeah.
Okay. Fine.
Yeah. Okay. Thank you.
Yep. Anyone guys who joined in the today's class or yesterday's class, if you have any questions regarding the training.
Sir, I have installed the Jupyter through command line, and you were talking about the Anaconda. So, will there be any difference?
Difference means you don't get all the libraries. You have to install them.
So, for practice purpose, we have to install Anaconda only.
It is okay. You already install. You are saying that you already installed, right? So work on it. Not a problem. But whenever there is no library was found, you have to execute a command called as an pip install. Just add this command pip install, which is going to be NumPy. So this is a way. In the case if NumPy was not there, you do this extra installation pip install NumPy.
Okay.
Yeah.
And for any kind of library, I have to install manually, right?
Manually you have to, but one time.
Okay.
Yeah. Yes, Ashok. Yeah, you can leave, Ashok. Yep.
That exclamation has any significance there?
It's an that means it is not a Python command, right? So the command is not a Python command, right? It's an OS command. So when you are executing any OS commands, we have to put exclamatory symbol. Otherwise, what
but
it
if
is
I'm using in the command line interface, I can just put pip install.
You can pip
Okay.
install. You can do the pip install because what it is going to be here is whenever you want to execute any operating system commands, like for example, I want to say which is going to be directory, for example. So what is the directory command? It's an OS command. So I'll say exclamatory directly. Then you will get all the what are the directory command output. It's an OS command, right? So I have to use exclamatory symbol like this. Now see, whatever the list of files and folders that are available in the directory, we are getting all the list here.
Okay, it's more like escaping to the command line or something.
Yes,
Can we assume like that?
Yes, absolutely. It is escaping to the command line.
Okay.
Right. Anyone else, guys?
I have a question, please.
Yes. Sure.
When is the link going to change?
When the link is going to change is, are you from, you today have joined, right? I think so.
Yes. So this is my first day.
Maybe 1 or 2 days it will take it. They will change the link.
Okay. So
you have to restart before the class. If you just once they change the link, they will send you the link saying that the link has been changed. Only generally what will happen here is the paid participants will get the link basically.
So once I make payments, that means this
then,
next session I'm going to start is going to be for Python. I will get Python videos, then continue with the class.
They will give you the Python videos.
Then I'll continue with the class wherever you stop with the demo.
You can do that. Yes, absolutely. It's continue 1 or 2 days. Don't immediately. 1 or 2 days you continue. After that, you can learn it. Do you have any prior knowledge of Python or don't have any prior knowledge?
I have prior knowledge of Python. I do.
Yeah, that is sufficient. How about the today's class? Are you able to understand?
Yes.
Yes, that is just continue 1 or 2 days. After that, we can think about that.
Okay.
Fine.
Okay.
Sir, regarding the materials, right? Is there some PDF material that you would be sharing?
Yes. I have the materials. Yesterday, actually, I got the access, but they didn't give me the permission to write the file. They have given only the read permissions only. Yesterday, I informed my team. So maximum, you will get once if I get the access, I will upload the materials.
So that will be having all the contents that you are covering, right?
Yes, all the contents I will be covering as of now.
Oh, okay. Yeah. Yes.
Fine. So I'll do one thing, guys. Just end up the session for today. So we'll meet on
installation.
Sir, yes. Sure.
Yeah. For the installation, there will be Anaconda, and it is written just me or all users. So you have to use just me.
Yeah, you can go for just me. That means in your system, right? Just me, sufficient.
Yeah. Okay.
Yes.
Sir,
yes,
yesterday you were sharing one Excel sheet regarding the study items. By the time I clicked download, the meeting was, and can you please share again?
Yeah, I'll share it 1 second.
Yeah.
Just give me a second. I'll share it.
Yeah.
Yes, everyone, you can, if you want, you can download the file, guys. It's nothing but the course content. So just download it, guys. Yeah, I given you. Just once you download it, once it's completed, let me know. I'll end the session then.
Okay, sir.
Hello.
Yes, hello. Yeah, Harish. Right.
Yes, sir. Like basically, I'm a working profession. So the thing is, like, I wanted to join this session because currently I'm working as a data engineer. So I want to upskill myself into data science. So sometimes I'm unable to join at 11 o'clock. So in that case, will I be getting a recorded session that evening?
Yes, by the evening you will get the recording session. Already the drive was updated. So let me show you the drive. So this is the drive. So you are getting the recorded every day-to-day recording you will be getting. So yesterday's class, I think 15th, 16th class was not yet uploaded. I'll check it out. So up to 15th, I think they have been uploaded. You can see those particular videos. So every day-to-day video, you will be getting the video. So you can get the access to them.
Okay. Yeah, that will be very helpful, sir. Sometimes I cannot join.
But one thing I recommend is please you have to complete the session before joining for the next session.
Yeah, sure.
Okay, because you will not be aware about what has been taught before. It's not like an offline class. If it is an offline class, somebody can help you. So this is the topic that has been happened. So better complete of it and then attend the next class.
Sure, definitely, sir. Thank you.
Fine.
Sir, one more thing. So when you're completing a specific topic, right? Think like if you're completing like a Python. So would you also recommend like what is the related certification we have so that it will be useful to develop in that career.
Yes, yes, but absolutely we are learning. Okay, absolutely. But coming to the Python, what we learn is a very basic level of Python. So we didn't learn about advanced level also. So as of now, it is not required. But in coming days, I can recommend you some certification courses. I'll recommend you. There are some free certification courses are there, provided by very top the top universities only. I'll just recommend you. You can just go through them once.
Okay. Yeah.
Okay.
Thank you.
Fine. Okay. So any more guys? Any more questions?
No, sir.
Yeah. So for today, we'll end up the session for today, guys. So tomorrow you don't have a class. So on Monday, we'll continue the session. Meanwhile, guys, who has already attended yesterday's and today's class, so if you really want to go ahead, so complete off the registration, you'll get the access to the videos. You can complete off all the backup sessions, what are the sessions that has been completed. So you can just go through them and you can just regularly continue from the Monday's class. Okay. So we'll continue on the Monday, guys. Maximum, we are closing the batch for this because previously we have 10 students, 8 students. So that's why we extended like this. So maximum we'll close up the batch up to now. What are the, I think 15, 16 students we're expecting. So once the 15, 16 students are there, we'll close up the batch and we'll continue regularly without having any disturbance. Okay. So thanks for today. We'll meet on Monday's class, guys. Thanks all of you guys.